Okay, we stopped here in this explaining the delta H. So now for computer solutions of the dispersion model, it is convenient to have an algorithm, right? So in this case, to calculate the stability class. The figure, the dimension 629 in FE exam handbook, this one has the effect on that. So SY can be calculated using AX to the power 0.894 and S is equal to C x to the power D plus F. Now where the constant A, B, C, D, and F are defined in table 6.3a, these equations were developed to yield SY and SZ in meters for downwind spin. So student practice example 9.5 in page 3638. So this will give you an idea. And I'll solve some problem also using some of those as much as I can explain. Okay, the inversion aloft. When the inversion is present, the basic diffusion equation must be modified to take into account the fact that plume cannot disperse vertically. That means it cannot go upward, it will go downward, right? So we mentioned that. So plume will begin to mix downward when it reaches the base of the inversion layer, figure 628, right? The following empirical equations is used to determine the vertical standard deviation of the plume at a distance of XL. So S is equal to 0.47 into L minus H. L is the height to bottom of the inversion layer and H is the effective stake height. So I think I have a picture to show you maybe somewhere. So if it happens, when the plume reaches twice the distance of initial contact with the inversion base, the plume is said to be completely mixed throughout the layer below the inversion. Beyond a distance equal to 2XL, the center line concentration of may be estimated using a simple equation. That means concentration would be E over 2 pi to the power half SYU then L. So L should already know, right, the distance and other thing. Where SY is determined by the stability of the layer below the inversion and the distance to the receptor. So SZ is not important over here, looks like, because it's not going upward anyway, right? So here is the equations, looks like the picture that I have. So this is my L, right? This is my L, S equal to L, SZ equal to, this is the equation. This is not right. This is not a right equation. This is XL, to whatever the distance is. So anything beyond this line, beyond this line, 2XL, we should be able to calculate the SZ by using this equation. I may have a problem that I'm going to solve here just to show that we use this equation. Student practice example 6.9, page 6.4b. I think the book has this one. If you practice it, it'd be good. So some of them I'll solve using the FE exam handbook. So this will also help us to understand the problem. So this is figure 629 for SY. So this has a distance downward. These are in kilometer. So these are stability categories. We'll discuss those: A, B, C, D, E, F. You remember that neutral, stable, and unstable. They have some kind of subcategories. Out of the 3, now they became 6. So I'll discuss those in here a little bit. So this is for SZ for this stability group or class A, B, C, D, E, F. So at the distance again, all of those distances. So here are the stability classes, okay? So it depends on the wind speed at 10 kilometer away. Less than 2, if it is the daytime, incoming solar radiation is strong, moderate sunlight, then it is A or B or both, or B. And if it is at night, then nothing, it doesn't matter. If it is 2 to 3 kilometer per second is the wind speed at 10 meter height, then A, B, B, C, E, F, and so on. So here are the neutral classes. D should be assumed for our overcast conditions during the day and night. Note that the 10-day forecast is not equivalent to overcast. So in this case, class A is the most unstable and class A is the most stable classes considered here. Night refers to those things in here and there. So in this case, class A is the most unstable, B is a moderate unstable, and C is the unstable. Okay, D is kind of like say stable, neutral. D is kind of neutral, and F is mostly most stable in this case. So this is from FE handbook. Looks like a little bit different, right? So, and in this case, what I'm going to do, this is from the book, right? So this is from the book. I'm not using the book one. I'm going to use this one. So always we try to use this FE exam handbook, whatever the handbook we have. So here it is A, B, B, A, B, B, C. Looks like they are very similar. So here at the one explains better. So A and B, B, C, and C, D conditions average the values of obtain each other. A is very unstable, B is moderate unstable, C is slightly unstable, D is neutral, E is slightly stable, and F is the stable. That's how we get the 6 category. So unstable, there are 3 unstable, 1 neutral, and 2 stable, right? So regardless of the wind speed, class D should be assumed for overcast condition day or night. So I think this seems to be better than the other one. So we can use this figure also to find some concentration. This one, CE over Q. So as I mentioned that Q is the emission flow rate, whereas in the book it's used the E value, right? C is the concentration, E is the wind speed. So if I know these numbers, this is a category A, B, C, D, E, F. And the numbers over here is like, say, effective stake height. Okay, these are effective stake height. So in this case, if the stake height is 70 meter, then and the class is A, then I should go find the value of C over Q, and also it's happening what distance this concentration will be happening. So this is not really concentration. This is a maximum could happen. This is the ratio of CU over Q per meter square. So if we multiply this one with Q over U, Q is the emission rate, U is the wind speed, then we should get the value of C, concentration in microgram per meter cube or gram per meter cube, or whatever the unit comes out to be. Okay, we'll use that to solve some problem and see what happens. So you remember that we said the A, B, and C, D, there are some parameters. So this table, this is from the FE exam handbook, I think. No, sorry, this is not FE exam handbook. I think this is from the book. So, but I'm going to use the same one here. We have a little bit different one when we use the FE exam handbook. I think this is from FE exam handbook. So in this case, stability A, then A, B, C, D. We get the values B, we got A, B, C, D, and F, all of them. You remember this is the one that we can get this value C over Q. We can get it from the graph, this graph, right? Or we can get it by using the equation. So this is the equation, exponential equation, A plus B ln H plus C ln H square D ln H to the power 3. H is the stake height, and A, B, C, D coming from here. Okay. So let's try to solve a problem and see how we can use the data that we learned before. So the table and the graphs and all of those. In example 6.4, calculate the downwind concentration at 30 kilometer y equal to 0, means we are not considering lateral dispersion of it, in gram per meter cube, resulting from an emission of 1976 gram per second of sulfur dioxide into a 2.5 meter per second wind at 1 a.m. on a clean winter night. So assume an effective stake height of 85, that means capital H, 85, and an inversion layer at 185 meter, that means this is capital L. Identify the stability and show all work. So this would be E for the book wise, and for the FE exam handbook, this would be the Q, right? This would be the Q. So I'll keep it in for a few seconds so you can read it, the question. You can read the question here, then we'll go to the solution. Okay, here is the solution. The first part we did using the book. So given stake emission rate E equal to 1976 and the wind speed E equal to 2.5 and things like that, H equal to 85 and L equal to 185. First, we'll determine the stability class. So based on the clear sky at night, wind speed is 2.5, table 6 to stability category is F. and check for XL using equation 624. Sz equal to, we get this one, it's 47. So with the stability class F is equal to 47, XL, it becomes at 10 kilometer in figure 630, right? If we go back to figure 630, then we'll see 10 kilometer. So 2XL would be 20 kilometer. So since we are looking for a 30 kilometer away and 30 kilometer is greater than 20 kilometer, then we can use the equation 625. That means a smaller equation. So then we need to calculate to SY. SY we can calculate using the equation A x to the power 0.894. So A we get from the table, right? We get from the table 34. Then we get 711.26. Then we'll calculate the C value using the equation. We put everything in here, we calculate, we get 2.4 10 to the minus 3 gram per meter cube. Okay, so it could be like say 2.4 milligram per meter cube, or you can do 2.4 10 to the 3 microgram per meter cube. So 1 gram is equal to 10 to the 6 microgram. We have to remember that. So that's the problem solution. This is the part I did it using the book ways. I don't know, let's see, yeah. I'm going to do the same thing using the FE exam handbook. As I said before, I'm saying it just for the purpose of comparison. But all of your homework and everything in the exam, everything you'll be following the FE exam handbook, not the book one. So the same problem I'm solving using the FE exam handbook approach. Tables and everything. Q equal to 1976. Wind speed is this. Everything is here. Determine the stability class based on the clear sky. 170. I think I have the older version. That's why page 170. Stability category is F. Now for stability category F, A equal to this from the table. You remember that from the table, right? So page 172. Using equation this, if we calculate it, I got 4.27 to the minus 6 per meter square. Then C max would be equal to CU over Q times Q over U. Q is this, U over U. I get 3.74 10 to the minus 3. You see, this one was 2.4 over there, right? This one was 2.4 using the book approach. Now I got 3.74 gram 10 to the minus 3 gram per meter cube. This is more conservative because we're getting more values. So that's why using the FE exam handbook approach is better. The same thing can be done by using the graph. I don't think I have it. You guys can practice it to use the graph and do it, right? So let me see whether I have it. No, I don't have it. So meaning in this case, you can go back to the graph, okay? If you remember the stake height, H is 85. And the class category is F. Okay, so if we go back to the graph, so for example, this is the graph. So it was class category was F, and the stake height was 85. So this is 100, this is 70. So in here somewhere, if I go here, this would be 95. So 85 would be somewhere around here, right? If I come back here, so this would be basically what this is 1 2 3 4 5 5 around 5 10 to the minus 6. Okay, CU over Q would be 5 into 10 to the minus 6. Now we can go back here and compare it with, so I have 4.79, very close to 5. So the same thing, as I said, can be done using this equation or from the graph. Okay, so I'll keep this one in for a few seconds there so that you can take a look. You can practice it. The solution is there. Everything is in my class note that I have, but here I'm trying to explain what I get from where. Okay. So I'm going to stop it here. So in slide number 165, so we'll start next one